Okay. All right, welcome everybody to the University of New Mexico Law and Mental Health Didactic Series. This series is hosted by the University of New Mexico Department of Psychiatry and Behavioral Sciences and the New Mexico Behavioral Health Services Division. We're so glad to have you all here joining us today. My name is Julie Bravko. I'm an assistant clinical professor in the Department of Psychiatry and Behavioral Sciences. Don't forget that next week we have Dr. Jody Koss presenting Enhancing Youth's Understanding of and Coping with Legal Involvement, Lessons from Studies of Dependent and Delinquent Youth and Their Families. For our talk today, please ask your questions in the Q&A anytime you feel comfortable, but just know we're probably not going to get to them until the end. As always, I try to get to as many of your questions as possible, but please forgive me ahead of time if I can't get to yours. For those of you that want CEs but are on a tight schedule, you do have to stay for the full hour, but you don't have to stay longer than that. We will probably be staying on a little bit after to try and address more of your questions. For those of you that are here for CMEs, those are the medical CEs, you want to sign in the chat now. For those of you that want the mental health or APA or counseling CEs, that's going to be at the end of the talk. So in the last 5 minutes, we'll be posting a link to our survey. Click on that, complete it, save a copy. We don't send those out. We don't save copies of them for you. So make sure you screenshot it or print it or do whatever you need to do with that. The recording link and PowerPoint should be up in about a week for this talk. If you don't see it after a week, then please reach out to us. And I think those are all the announcements for today. I am now going to introduce our speaker. We have with us today Dr. Aaron White. Dr. White is a biological psychologist. He works for NIAAA. He is interested in how alcohol affects the brain and behavior, and you're going to hear more about his amazing work today, but you can always contact him for more information. Dr. White, thank you so much for being willing to present for this series. I'm honored to welcome you, and I want you to know that we're so grateful for your time and expertise. I'm now going to turn it over to you.
Oh, thank you, Julie, and thank you also to Alex for all of his technological wizardry. I'm delighted to be here. This is a topic that I still find fascinating after 2 decades or more of studying it, and so I want to share with you an overview of what I know about blackouts, and I'll try to make sure that I fit in some stuff that you won't find in just your typical review article. So it's worth your time and attention. But so in the next hour or so, I would like to explore with you what we know about alcohol-induced memory blackouts, these gaps in the tape, these missing chunks of time in our lives that occur under certain circumstances when people drink alcohol. And we're going to explore the history of them. We're going to explore what we know about how prevalent they are, what happens in the body that causes them. We'll talk about some differences between males and females and some other factors that contribute to the likelihood of blackouts beyond just how much you drink. And then we'll explore, to the extent that I can from a research standpoint, the legal implications of alcohol-induced blackouts. There's some fascinating science-like research on this topic. It's not really my field of expertise. I am a biological psychologist, but we can at least explore what some of the implications of blackouts might be for some of the questions that the people in the legal field ask. So first of all, what are blackouts? Well, blackouts are episodes of amnesia, anterograde in nature, meaning you have a lack of memory for things moving forward in time. Anterograde amnesia leading to an inability to recall events that transpired while intoxicated. So in other words, you drink alcohol, and then for a period of time, the brain is unable to record memories for what's transpiring, so that when you sober up, the memories aren't there. There's a gap in the tape. It's like somebody edited out a chunk of your autobiographical record. Sometimes never to be found again, and we'll explore the circumstances around that. Blacking out is still very commonly confused with passing out, and they are in fact mutually exclusive, meaning you can't have one if you have the other. If you are unconscious, you aren't in a blackout, because a blackout implies that you are conscious. I put an asterisk there, and I'll come back to that asterisk in a moment. A blackout presumes that you are in that moment functioning, aware, able to make volitional choices, you're just not able to recall these things the next day. Passing out implies you are unconscious. You have lost consciousness. You will look like you're asleep. You might even be asleep, or you just might be so anesthetized that you are unconscious. But they are two very different things. Now, as we'll explore later, they can both happen in the same night. You could be in a blackout and then shortly after that pass out, because blackouts tend to occur at higher blood alcohol levels. You could pass out and wake up, and in that moment be in a blackout that maybe you weren't in before you passed out. So it's not that they can't happen in the same night, it's just that they aren't the same phenomenon. They're actually quite different based on the role of consciousness. Blackouts only refer to the memory impairment, and we'll come back to this point time and time again in the next 45 minutes or so. A blackout is just the memory impairment, which means that blackouts don't cause anything. Blackouts have never caused somebody to do anything other than not remember what they were doing in the midst of the blackout. So how somebody behaves during the blackout, it depends entirely on what's going on in other brain areas. As we'll see, the blackout part seems to be due to particularly to activity in the hippocampus and a few other related memory areas. But the blackout is just the memory piece. It's not the other things that happen. Now, in reality, when people black out, they often are so intoxicated, they behave in ways they might not normally behave, take risks they might not normally take. And so it's not uncommon for people to wake up, realize they don't remember what happened, and later find out that the things that happened were not typical behavior for them. But at the end of the day, the blackout is just the memory part. So here's an example of the kinds of things it's just an example of a blackout that I'm going to come back to later on when we discuss the contribution of various brain effects of alcohol to behavior during blackouts. This is actually a spring water commercial from Spain. There's no sound for you. I can hear it, but it doesn't work in Zoom, but it doesn't matter. The commercial, just watch it play out, and it tells a story that we'll come back to and discuss when we talk about what alcohol does to the brain while you're intoxicated. So let me see if I can get this going. Here we go.
There's a downside to leaving all your common sense at the bottom of a glass, as we see in this piercing commentary. Second drink. Better ask for Mondari.
Now, it's a pitch for spring water, and they're basically saying, don't overdrink, drink spring water instead, or this might happen. But what happens in this commercial is, presumably, a guy goes out, drinks too much, wakes up the next morning, realizes he engaged in some risky behavior, doesn't seem to remember that he did it. So we'll come back to that in a little bit and explore the different parts of the brain that probably contribute to different aspects of that type of scenario. And I'm going to give you a real world example that is basically exactly what happened in this commercial. Research on blackouts is still pretty new. It turns out, as I'll show you, we're going to go way back to the beginning of research on blackouts in the 40s. It really isn't a long history of study. It's a fairly new concept from a scientific standpoint, even though I presume people have been experiencing blackouts since they started drinking alcohol, at least 9,000 years ago. But over the years, there's been an increase in the interest in blackouts. And now we've got about 17, there are 22 papers in 2021. So, a couple dozen papers a year on blackouts. Interest is picking up. We'll explore why some of there's kind of a limited amount of research on blackouts. They're very hard to study. You're basically studying something that is defined by a lack of memory for events that occurred. But going back to the beginning, the first report on blackouts that I'm aware of came from a statistician, alcohol researcher named E.M. Bunky Jelinek, who, while at Harvard, published a paper called The Phases in the Drinking History of Alcoholics. It was based on survey data he collected from the Grapevine magazine, which was the magazine for Alcoholics Anonymous. There were 1,600 subscribers. He got responses back from 158 people, and he used 98. I'm going to tell you something important about why he only used 98 in a moment. But in the questions that he asked, when was the first time in your life that you experienced a blackout? Which he defined, operationally defined here as waking up in the morning after a party with no idea where you had been or what you had done after a certain point. And so when he did that, he found out that the vast majority, about 90% of people with alcoholism reported blackouts. Well, from that, he concluded that if alcoholics have blackouts, then blackouts must be an indication of alcoholism. And so for 50 or so years, that was the general consensus, was that if somebody's having blackouts, they're probably an alcoholic or they're on their way. He believed that the blackouts in somebody who was young was an early or prodromal sign of alcoholism. It was one of three things that he said were key characteristics of somebody with what he believed was the disease of alcoholism. And those included losing control over drinking, experiencing blackouts, and going on benders, long stretches of intense intoxication. So this all fit into a scenario for him in which alcoholism is a disease and it's progressive and it goes through stages, and blackouts are a key part of those stages. Interestingly, the reason he only used 98 out of his 158 responses included some of them were from women. And he noted that the experiences that women reported, even back then, were far different than the experiences that men reported. And so he didn't want to essentially contaminate the men data with the women data. And we'll come back to this notion of men, differences in men and women and blackouts shortly. So in the 1960s, in enters a MD psychiatrist named Donald Goodwin, who really started the formal study of blackouts from a scientific standpoint. And this was at a time when the ethics rules were pretty fuzzy. You could do some things that you just would never get away with doing as a scientist now. And I'll share with you some of the methods he used to study blackouts. But I want to start with the question of where did that name come from? And he explores this, Donald Goodwin does. And he says, he talks about how people are really unclear about what blackouts are. And he says, contributing to the confusion may be the word blackout itself. The word has a rather curious history. According to Keller, it may have originated as a corruption of blank out, the latter being derived from pulling a blank. Pulling a blank, in turn, may have been originally a printer's term for pulling a proof sheet which comes out white or blank because of a failure to ink the type. After World War I, as aviation became popular, the word blackout entered the vernacular to describe disturbances of consciousness experienced by pilots. Keller believes that possibly by analogy with the aviational blackout, blankout became corrupted by the dropping of the sometimes unheard N to make blackout. In any event, blackout is an unfortunate term. Patients confuse it with passing out, and so do doctors. So this issue we have with confusion between blacking out and passing out existed certainly as far back as when the term blackout entered the vernacular. So in the 1960s, as I mentioned, Goodwin and a few other people, there was kind of a little surge of research on blackouts in the late 60s and early 70s. And Goodwin was really the first to recognize that blackouts aren't necessarily an indication of amnesia. He says, given their presumed importance as predictors of alcoholism, blackouts have been surprisingly neglected as a subject of research. Amnesia experienced while drinking obviously occurs rather frequently among alcoholics, but there's reason to believe it also occurs rather frequently among non-alcoholics. In neither group has this phenomenon been studied systematically. The present study was designed to investigate blackouts in a group of hospitalized alcoholics. And so Goodwin did a series of studies where he basically gave alcohol to alcoholics and tried to produce blackouts. And he had success in doing this. And in one of his studies, published in 1971, he recruited 10 subjects, all males, middle age, I think they were all white, from an unemployment office in St. Louis. And he gave them about 18 ounces of bourbon, which is what, about 13, 14 shots, I think. And every 30 minutes, he went through a scenario where he'd show them something. It was a toy for 1 minute, and then he'd show them a scene from a porn movie for 1 minute. And then he had another condition where he figured he wanted to make sure that the lack of memory wasn't just due to the fact that the stimuli to be remembered weren't novel or exciting. So he had a condition where he'd walk up to the subjects and say, hey, are you hungry? And they'd say, yeah, I'm hungry. And he'd take the lid off a pan and there'd be dead mice in it, which in his mind would evoke a strong enough emotional response that it should get remembered if possible. What he found was that everybody could remember things at 2 minutes. Everybody had intact memory at 2 minutes for these stimuli that he shared with them. But about half of them didn't have memory 30 minutes later. And if they didn't have memory 30 minutes later, they didn't have memory a day later. And so this gets to our current understanding about blackouts, that it's really a failure to transfer information from relatively short-term storage into long-term storage. That's where the gap in the tape comes from. It's the failure to take the information the brain has collected and is currently examining in memory and convert that into long-term storage. Because even though they couldn't remember it the next day, all of them had memory of it 2 minutes later. Several other studies found something similar. A researcher named Ryback took hospitalized alcoholics and gave them access to alcohol ad lib. I think it was as much as they wanted for, I think this was 7 days. Yeah, 7 days for 4 subjects, 12 days for 3. They're in the hospital for alcoholism. He gives them free access to alcohol, measures their blood alcohol levels, and then tests their memory to see if they blacked out. This is just a small section of the studies that were done around this time, including one with an IV alcohol administration. I mean, researchers were really getting creative in how to try to cause people to black out. A couple things came from this research. One is not everybody blacks out, not even at very high blood alcohol levels. Can you get some of these seasoned drinkers to black out? In one study, Goodwin tried to cause medical students to black out, and he found that many of them vomited before they got to the blood alcohol level needed to black out. And so it's not like anybody just blacks out if they drink too much. The other is this notion of memory staying in short-term storage, just not being transferred to long-term storage. And then finally, a very important observation from these studies was that it was almost impossible for researchers to tell that these individuals were in a blackout, even though they're watching them drink, they're measuring their BACs, they're testing their memory, they're having conversations with them. If at all, some of them looked intoxicated, maybe very intoxicated. Some looked perfectly intact with coordinated thinking and speech, as one study says. So there's a lot of variance in who has blackouts, when, and what they look like during them. The only consistent theme is the blackout itself, the missing information for events while someone is intoxicated. And so this led, this research led Goodwin to propose there are actually 2 kinds of blackouts that basically differ in severity. They're probably not different, they're just different severities of memory loss, not 2 unique phenomenon. But one he called fragmentary blackouts. These were blackouts where the person has spotty memory for events that occurred, and often thinking about those events, what memories do exist, can pull up memories around the fringes and start to fill in the missing pieces. Although by definition, they're only still blackouts if at the end of this time of filling in pieces, there's still something missing. But fragmentary blackouts seem to be, as we'll see, the norm. This is the type of blackout that people tend to experience, where they don't remember leaving the bar, but they remember being at home, and then they remember brushing their teeth, and then they wake up the next day. Another type of memory blackout that he characterized was the en bloc, the just total blackout. This is one where people tend to be aware that they had a blackout because there's just a chunk of time missing. It has an onset. I don't remember anything after this point, and then it often has a distinct offset where now I'm back online and remembering. Quite probably, yeah. Let me stop with that description right there. But regardless of what type of blackout one has, it seems to come down to this issue with just a very basic model of memory formation, that information comes in, gets bounced around the various circuits in the cortex, gets funneled down into the memory areas, as we'll see, and the memory areas then convert that short-term information bounce into long-term storage so that you can access it later. Something goes wrong in the transfer or the encoding of that information from short-term to long-term storage. And we have some good ideas. They're pretty simple for how this probably happens. And we'll come back to them. But the question is, in terms of the brain, where is this taking place? I mean, if you had to posit a mechanism for how alcohol was preventing this transfer from short-term to long-term storage. What would you posit would be the potential cause of that? Well, in the late 1960s, early 1970s, Goodwin sort of picked up on research that was going on looking at how the brain creates memories in general. In the 1950s, there was a patient by the name of HM. And HM was a young man with epilepsy who had his hippocampus on each side of the brain taken out to try to control the epilepsy. And it somewhat worked to control the epilepsy. But what they quickly realized was he couldn't make any new memories. If you walked in and met him, had a conversation with him, he could talk to you for a while and talk about the weather or whatever. And then when you leave the room and come back in, he'll have no clue he'd ever met you before. And so he had other damage to the brain, but the primary source areas of damage were the hippocampus. So, Goodwin picked up on that, and he says the specificity of the memory loss in these syndromes, blackouts, and he's talking about some other syndromes too, but the specificity of the memory loss in these syndromes is reminiscent of memory disturbances in patients with bilateral hippocampal lesions and suggests the possibility that alcohol may specifically affect hippocampal regions possibly involved in memory consolidation. And so this is sort of where I come in. I mean, not in the I didn't come in the 1970s, but this area of research, the brain areas and what may be involved, that's sort of where I got very interested. I had always been fascinated by blackouts. I had a friend in high school who had them. And as an undergrad, I found a laboratory where there were researchers studying how alcohol affects memory in the brain, including the hippocampus. And I just thought, that's what I want to do. And so that's the direction I headed in with my career. And we'll explore how this whole system seems to work, what it is that alcohol is doing in the brain that seems to produce these blackouts. But first, if you look here at this image, you'll see it's just an image of the brain, a drawing of the brain with a couple areas highlighted. And we're going to talk about these areas that are highlighted, the hippocampus, the amygdala, and the septum, throughout the rest of the talk, because the hippocampus is the primary target by which alcohol produces blackouts. There seems to be no doubt. But if we talk about other behavior during blackouts, we've got to talk about some of these other areas to help explain why people tend to act the way they do if they drink enough to black out. But in essence, the way the brain seems to work here is that you have an area, this little area called the septum, which sends excitatory and inhibitory signals to this larger area, the hippocampus. It basically makes the whole hippocampus, the electrical charge of the hippocampus, rise and fall. And so it gets a little bit more positive, a little more negative, a little more positive, a little more negative. You can actually hear this structure in electrophysiological recordings just sort of humming along, rising and falling. And when a rat, anyway, is paying attention, it rises and falls at about 6 to 9 cycles per second. What seems to happen is that as you're experiencing your life, all that information being processed about the location you're in, the smells, the sights, all of this sort of sensory information that we're pulling in gets is used to create patterns to understand the world around, perceive the world around us. And then information about these patterns is funneled down into the hippocampus to be tied together for later recall. And so the hippocampus, the job of the hippocampus is really to record or somehow tie together all these things that are going on in your current experience so that later you can recall the experience that took place. This is just an overly busy slide showing you what I just told you. The medial septum sends these positive and negative inputs to the hippocampus. Information from the neocortex flows down through an area called the entorhinal cortex into the hippocampus. And the reason that this structure seems to rise and fall is to create a gate, so that information coming from the cortex only gets into this hippocampus if it hits at exactly the right time. So for instance, if you look at a rat and the way it moves its whiskers as it explores, it moves its whiskers perfectly in time with the rising and falling electrical properties of the hippocampus, so that when the olfactory information comes in, gets processed, and hits the hippocampus, it can get in, get routed through the hippocampus, and somehow whatever the hippocampus does, it ties it together to create later memories, and also to help us explore the world. The hippocampus does some different things. Anyway, the point of this slide is really this little tiny area called CA1, which is right below the word hippocampus. We know from a patient named RB who died in the 1980s that he had damage just to this little layer, CA1, a little layer of cells in the hippocampus. Those cells were wiped out. He could not create new memories. He looked like HM, even though he didn't have the whole hippocampus taken out. He just had this little layer wiped out. So we know this little layer of cells is central to creating your memories for your autobiographical record as your life unfolds. And so this lab I went to, this is 25 years ago, this lab I went to had the ability to put electrodes right next to those little neurons in CA1 in rats and record their activity as they ran around and explored. And I'm not going to get into all the detail, but I want to tell you I just want to tell you one thing about this, two things about this slide. One is that's a rat on a maze with a headlamp. We could use the light to track where it goes. And on the right, what you see is over 15 minutes, wherever the rat visited on the maze gets a square. Any place the cell fires action potentials gets a color. The darker the color, the more the action potentials. So you can see that this particular cell in CA1 became very active whenever the rat ran through this one little area. And you have different cells that represent different areas of the room you're in at a time, like the room you're in right now. And as you move around, which cells are active changes, and that updates the brain about where you are in the world. So this little cell said every time the rat went through this part of the maze, the little cell said, here's where you are right now. So this is a sober rat. This is a rat at a 0.1 BAC. So just a little bit past the legal limit for driving for humans. And what you can see is, first of all, the rat doesn't run around as much, but look, there's really no activity. There's very limited activity. The cell is still doing its job, but it's not doing a very good job of charting, updating the brain on what the rat is doing. And here's the rat sober. And you can see that the rat's hung over here, but the cell comes back. And so we know that if you kill those cells in CA1, you make no memories. We know now that alcohol shuts off these cells in CA1. Here's a very drunk rat at a 0.15, which is really about where we get into seeing blackouts happen, right around this level. You can see that the cell is basically just shut off in this rat at a 0.15. Can't really give rats more alcohol beyond this. They just decide to take a nap on the maze. So, but the point being that alcohol shuts these cells down. And if that's all alcohol did in your brain, that would be enough to give you a blackout. Let me just keep moving. It basically does it. Now, how does it do it? It does it by directly affecting the cells in the hippocampus, but more so by shutting down the medial septum. It's basically like pulling the power plug on your TV. There's no more rhythmic, positive, negative signal. And it suppresses input from these cortical areas where the hippocampus normally gets its material to create memories. But at the end of the day, the hippocampus is at the center of this. So there are lots of ways that alcohol could do this at a molecular level. But one of the receptors that has been studied quite a bit in terms of alcohol and its effects on the brain is the GABA receptor, gamma aminobutyric acid type A receptor. This is a receptor that when it's opened, it suppresses a cell. It basically inhibits it. It just puts the brakes on it. And alcohol opens that receptor. And so it suppresses activity in cells. It's part of how alcohol affects every part of your behavior, from balance to memory to being alive, is through this very ubiquitous receptor. That's also the receptor that benzodiazepines and the Z drugs like Ambien and Lunesta act on. And so alcohol and these other drugs act on this same complex. Not surprisingly, benzodiazepines and Z drugs produce blackouts all by themselves. And when you add alcohol to them, there's a much higher likelihood of a blackout when the two are combined than if either one is used alone. I had not been aware of this until Dr. George Koob, the director of my institute, pointed out to me. There are a couple papers written about something called traveler's amnesia, which is basically a blackout that happens when academics take sleeping pills and alcohol on planes. There's literally a phenomenon where people go to conferences and don't remember being at the conferences because on the plane, they took a benzodiazepine or a Z drug and drank alcohol. But like I said, benzodiazepines and Z drugs can do this on its own. Currently, in the prescribing materials for these drugs, at least in this case, I have the Lunesta, Ambien, Zolpidem, Ambien up. They describe it not as blackouts, but complex sleep behavior. So they say complex sleep behaviors, including sleepwalking, sleep driving, and engaging in other activities while not fully awake, may occur following the first or any subsequent use of Ambien. Patients can be seriously injured or injures others during this complex sleep behaviors. Such injuries may result in a fatal outcome. Other complex sleep behaviors, like preparing or eating food, making phone calls, or having sex, have also been reported. Patients usually do not remember these events. And then they warn about combining with alcohol. Well, I can guarantee you these are not complex sleep behaviors. These are blackouts. It's just inconceivable that in someone's sleep, they engage in this sort of level of complexity. This is more of conscious decision-making and lack of memory. This is a blackout. It's not complex sleep behavior. Call what you want to call it, but it's a blackout. So let's step back a little bit and talk about what alcohol does to the rest of the brain and how the different aspects of alcohol's effects on the brain contribute to behavior while intoxicated, and in particular, behavior while intoxicated and in a blackout. And so going back to the 1930s, a paper by Fleming, he writes, "The striking and inescapable impression one gets from a review of acute alcoholic intoxication is of the almost infinite diversity of symptoms that may ensue from the action of this single toxic agent." This is a pretty simple compound. It has such diverse effects. It is, if it were, people sometimes refer to drugs, recreational drugs, as tools. I suggest that if that's the case, alcohol is a sledgehammer. It just really does, it impairs the brain in so many different ways. For the longest time, alcohol was thought to act like an anesthetic. It just touches the cell membrane, it makes it more fluid, and then the cells can't function, and everything gets shut down. Then in the 80s, there was this notion that no, alcohol has very specific effects. It affects GABA A receptors here. It doesn't affect GABA A receptors here. And it became clear that alcohol actually has some pretty selective effects when you really look at it closely. But it seems that there are so many selective effects of alcohol that we kind of get back to a general effect again. Alcohol has so many specific ways of messing up brain function that collectively it adds up to just sort of widespread disruption. But some behaviors are more effective than others. And some people are affected in different ways than others. And so it is again, as Fleming says, it is a simple toxic agent that has such widespread diverse symptoms. And so we all know that as an individual, if you start drinking alcohol, the more you drink, the more impaired you're going to be. And the impairments tend to run through things like, you get mild euphoria, you get mild impairments in balance and coordination. You start to get some short-term memory effects, and this all happens before 0.08, which is a legal limit for driving. Once you get to 0.08 or higher, you start to have bigger impairments in coordination and balance, bigger impairments in memory. At some point, you can drink enough alcohol to directly shut off the brainstem vital areas, in part via GABA A receptors, and die. And so it is a toxic agent that on the way to killing you gives you some properties, some effects that people tend to enjoy. And how much alcohol it takes for people to experience these various impairments, it really just, a lot of it does depend on the individual. With blackouts, it clearly depends on the individual. As we'll see, there is no single threshold beyond which every person has a blackout. Some people just don't seem to black out. Some people tend to black out at relatively what we call lower levels of alcohol. And so we're going to talk about those effects. We look at the brain, and I'm going to go back to a couple of brain areas that are important for understanding how people function during periods of intoxication, whether or not they're in a blackout. On the back of the brain there, you see the cerebellum. That's, of course, a structure that's involved in posture and balance and coordination. Clearly, the cerebellum is affected by alcohol, and that's why people have an unsteady gait, have a hard time engaging in coordinated activities. The amygdala is very important here. The amygdala is an area of the brain that is essentially it does a lot of things, but one of the primary things it does is it serves as sort of the smoke detector for you for danger. When it detects danger because it sees a pattern that looks like a bear, or it recognizes a smell, or it detects some element of danger in the environment, the amygdala triggers feelings of vigilance, paying attention. It triggers feelings of anxiety, restlessness. It makes you want to do something to deal with this thing that's a threat. And the amygdala is annoying for us because in the modern world, it goes off all day. It's always telling us that there's something to worry about, something to be afraid of. It's one of the reasons that people like alcohol. Alcohol suppresses activity in the amygdala, beginning with a drink or two. And by suppressing activity in the amygdala, it reduces your feelings of anxiety temporarily. It also suppresses your recognition of fear and danger. And so in this way, alcohol contributes to risky behavior by making you less likely to recognize you're about to do something dangerous. You might recognize it cognitively. If you were to ask somebody, do you realize that's dangerous? They might say, I do, but they don't have the feeling of fear that goes with the behavior. So it's easier for them to engage in it. The prefrontal cortex, which helps us regulate our urges, helps us assess our circumstances, and helps us make good decisions, is also impaired by alcohol beginning with just a few drinks. So if you think about this, the combination of suppressed prefrontal cortex and suppressed amygdala, you have faulty decision-making, difficulty regulating behavior, and a less of a sense of fear or anxiety about your activities, which can culminate in things like, it's spring break, people jumping off of the roofs of their hotel buildings into swimming pools. Not something they would probably normally do without the alcohol, and not something somebody with a highly functioning amygdala or prefrontal cortex would do. And so it is possible that during a blackout, these areas of the brain are severely impressed as well, meaning that the behavior the person engages in during the blackout may not be their normal behavior. But there are times when people experience blackouts without much evidence of impairment in the cerebellum, for instance, balance and walking and posture, and the amygdala, sense of danger and fear, and then the prefrontal cortex, decision-making and impulse control. People can appear perfectly cogent and able to make wise decisions for themselves in the moment, but yet will not have memories the next day. I don't know how often that happens versus how often people are in blackouts and they're making very poor decisions because of disrupted brain areas. But just know there's a range of how serious the other impairments can be in people who have loss of memory or lack of memory the next day. So let's tie this all together. I showed you that clip at the beginning about the guy and the piercings, and this is something that happened in 2004. Guy goes to Cancun and he says, this guy, he woke up from a booze-induced fog with a half-inch stainless steel ring pierced through his lower lip. He doesn't remember getting his lip pierced. I don't know how I got it or if it hurt when I did, says this young man who was partying at Disco La Boom with his University of Washington pals when the pre-dawn procedure apparently occurred. I just remember beer and tequila before waking up and seeing it in the mirror. So when you think about all that had to go on in this scenario, he apparently, we don't know because he doesn't know, but apparently he voluntarily made the choice and paid to have somebody put a hole through his lip. It involves a lot of pain. It involves poor decision-making. It involves, for normal people, it probably involves some fear and some anxiety. We don't know what happened to this young man other than he doesn't remember and he has a piercing in his lip. But blackouts aren't just for mundane things like brushing people's teeth. They can be for serious events. And I want to mention something about that. As of right now, I don't think there's any evidence one way or the other for sure whether emotionally charged memories are more likely to get stored during a blackout than mundane. It certainly seems that the hippocampus is hobbled. It's not making memories. It doesn't matter whether it's pain from getting your lip pierced or whether it's, again, brushing your teeth at the end of the night. It seems like when the hippocampus is off, it's just off. Normally, experiences that are emotionally valent, they have a strong valence. They're arousing, they're things that have real meaning, are more likely to get recorded. I mean, that's why we remember where we were on 9/11, et cetera. It seems like during a blackout, that doesn't apply. Again, seems, we don't know for sure, but it certainly seems from the research we have, the anecdotes that we have, that if the hippocampus is offline, it's offline. It doesn't matter if you're being chased by a bear or if you're playing a video game. It's just not going to get recorded. But again, that could change as more research is done. How common are blackouts? We don't know how common they are in the general population, but we know from, this is a study that I did in 2002 with my mentor at Duke at the time, Scott Swartzwelder. Basically, I had been studying the neurobiology of blackouts, and I was doing my rounds at conferences and giving presentations and talking about how blackouts happen. And I got quite a few people responding that, well, yeah, but blackouts only happen if you're an alcoholic, so this really isn't relevant to a typical drinker. And I would say, no, blackouts happen a lot to people. And they would say, well, show me the evidence. And there wasn't that much evidence at the time, just a few survey studies suggesting that in people without problems with alcohol that we know of, that blackouts can still happen. There just really wasn't much at all. So this was just a basic study, a survey of about 800 college students. And what we found was that about half of them had experienced a blackout at some point in their lives. 1 in 5 people who drank alcohol at any point in their lives had 4 or more. And we found that about 1 in 10 people who drank in the past 2 weeks had a blackout. The blackout was defined as waking up in the morning, not able to remember places you went or things you did. And so to me, that captures a blackout. And to the extent that it does, it means the data show they're very, very common. Very common. And it's unlikely that all of these students are on their way to developing alcoholism. It just seems like you don't have to be an alcoholic. You don't have to be on your way to alcoholism to experience these phenomena. A more recent study, this is from 2019, a survey of about 50,000 college students from the American College Health Association. In students who drank alcohol in the past year, about 1 in 3 had a blackout in the past year. And it's about 29% males, 29% females. I mentioned the male-female difference because if you go back 10 years in this survey, there was slightly more people had blackouts. It was like 34%, but it was way more males than females. And so this narrowing reflects the fact that young males are drinking less, while young females are drinking more. And young females are experiencing more alcohol-related harms as a result of drinking more. So now it's about even, about a third of males, a third of female college students anyway, report blackouts if they drink. What do people do? Well, this is where things get really tricky. We know from those laboratory studies from the 60s and 70s what people did then. And we know that people could have conversations, they could threaten to get in a fight with somebody, they could do mundane to emotionally intense things and not have a recollection of it. But from a research standpoint, where you can't give people enough alcohol to produce blackouts, it's very tricky to understand what people do, because you're basically asking them, what did you later find out that you did that you don't remember? That's what these data show. Not really how often do people do various things, but how often do they find out they did various things. A third of people said they later found out they insulted somebody while they were drinking. About a quarter spent money or engaged in some form of sexual activity. I wish I had asked these questions a little better. Back then, I was still a full-on neuroscientist, and I was just borrowing from what was in the literature. So I don't know what sexual activity means here, but a quarter of people did it and don't remember. And surprisingly, about 5% said they had unwanted sex, which means somebody had to inform them that they did, or perhaps they had fragmented memories. But it shows us that people can engage in a very wide range of behaviors that involve a lot of complexity and not remember it. And these are young people who, again, presumably are not severe alcoholics. How much alcohol do you need to cause them? Again, we don't really know. From the earlier research involving alcoholics, hospitalized alcoholics, there's some evidence that fragmentary blackouts start at around a 0.12, and that en bloc blackouts start around a 0.2 or a 0.22. But these are people who have a very seriously long history of heavy drinking. We don't really know how much it takes for somebody who's, say, not on the spectrum for an alcohol use disorder, that they're just a social drinker who drinks too much. There's one study where people who were arrested for alcohol-related event, like driving under the influence or underage drinking, were contacted the next day and asked questions about their memory. And what the researchers found was that at about a 0.22, you've got a 50-50 shot that somebody at least is missing something, or they had a complete en bloc blackout. If somebody tells you they have a 0.22, these researchers would say it's about a coin toss whether they had a blackout. This is tricky because, first of all, you're calling people who just got arrested for something. And we know from literature, particularly in the Netherlands, that if you ask people who are in prison whether they remember their crimes or whether they were in a blackout, the vast majority will tell you they were in a blackout. So we just don't know how good these numbers are. But we think it looks a little something like this, that alcohol starts impairing encoding even at a very low level, even at a 0.05, about 0.2 drinks, you start to have some mild impairments in encoding. If I gave you a list of words to remember, and then I came back half an hour later, or even 10 minutes later, or the next day, there'd be some decrement in your ability to remember those words. And so, you start getting memory impairments at a 0.05, but I wouldn't call those blackouts because you will still remember having learned the list. You just won't remember all the items. But when you get up to about a 0.12, that's about where you start to see these fragmentary blackouts happen, where people really, they say, I did what? Oh, we went there? I don't remember that. And then, oh, now I remember. Oh, I didn't remember that. And there may be some missing pieces at the end, but they can still they can still fill in some of the gaps. When you get up to about a 0.2, 0.25, that's really where, from the research, it seems that these serious en bloc blackouts are more likely to occur. Again, speculative. There's no guarantee, but I can tell you that it would be very unlikely, unless somebody has unique circumstances, to have a fragmentary blackout at a 0.08. It could happen, but it's not terribly likely. And once you get up into the 0.2s, that's really where you start to see more complete blackouts. By the way, one study shows that in a laboratory, when you take college students and you give them alcohol in a laboratory, and you look at mild explicit memory impairments, just their ability to memorize items on lists, for instance, somebody who's sensitive to a small amount of alcohol, say at a 0.06, a couple of drinks, somebody who's more sensitive to small doses of alcohol on memory are also more likely to report blackouts. It seems to be that on this sort of spectrum, again, you have alcohol, it's all the same thing. You're dealing with impairments and encoding, and it's just a question of the severity of the impairment and encoding. So it ranges from mild all the way up through fragmentary and then complete. It doesn't seem like they're unique phenomena. They seem to be on the same sort of scale. Again, this could all change, but that's what it seems like. So there are a lot of things beyond a person's blood alcohol level that play a role, though. How in some of these earlier laboratory studies, it was noted by several researchers that sometimes people would not experience a blackout, even though they were at a BAC beyond when they had the blackout yesterday. And one of the key factors seems to be how fast you get alcohol into your body. So going down the list, I'm going to read this quote from Goodwin. Blackouts usually occur erratically. Comparable amounts of alcohol do not always produce memory loss, and it has not been possible to predict when an intoxicated person will suffer amnesia. During the amnesic interval, the person may function reasonably well and perform complicated acts. So it's just a bit unpredictable, even within the same subject. And so, here's some of the factors at play. Predisposition to memory impairments. As I just mentioned, if you're sensitive to small memory impairments from alcohol, people tend to also more likely to report blackouts. There's a genetic association here. If one twin blacks out, The other twin is more likely to black out too, even after you control for their drinking. So it's not just that they both drink a lot. There's something left over, something beyond the drinking level itself that the twins share that increases the chances that they will have a blackout. And that's been found in several studies. It could be as simple as different density of different subtypes of the GABA A receptor in the hippocampus, or another receptor, the NMDA receptor. It could just be that simple, just a small change in receptor density. Being female, several studies suggest that being female is associated with an increased risk of blacking out, even after you adjust for body weight, level of alcohol consumption. And there are some studies, at least one lab study I can remember, where being female makes you more susceptible to even these smaller impairments in memory, which might fit with females being more susceptible to bigger impairments. I'm going to revisit the being female aspect in a moment. A big aspect of predicting whether somebody will black out is how quickly the alcohol gets into their brains. Lately, this topic has come up. I've gotten a few emails over the years, and then this has come up, I forget where, in the last week, about after people have gastric sleeve surgery. One drink may be enough to cause you to have a severe blackout. You have little stomach to serve as a reservoir for the alcohol. It doesn't get emptied slowly into the small intestine. It basically goes straight into the small intestine, straight into your bloodstream, straight into your brain. It's the difference between like snorting cocaine and crack cocaine. It's just an issue of how quickly it hits the brain. When people drink quickly, even if you've got an intact stomach, that is strongly associated with blacking out. Drinking highly concentrated drinks, which tend to get absorbed more quickly, although at the very high levels, at very high concentrations of alcohol, it may actually irritate the stomach and make it empty slower. But in general, high concentration means it takes less time to get emptied into the small intestine, which means it gets absorbed faster, hits the brain faster. Empty stomach is huge. And why is it, we're going to see a slide in this in a second, but why is it that getting alcohol into the brain fast matters here? The hypothesis still is that doing that circumvents something called acute tolerance. We know if you drink every day for a year, you become less sensitive to alcohol. Well, it turns out that even within one night of drinking, across the night of drinking, you become less sensitive to alcohol. You develop what's called acute tolerance as soon as the alcohol hits the brain. The brain starts adjusting. So the second drink will not have as big of an effect as the first. And the third will not have as big an effect as the second. And so if you were to measure somebody's blood alcohol level as it goes up and comes down, and you test them on the way up and the way down at the same point, say a 0.08, there are some circumstances where you find bigger impairments on the way up than the way down because of acute tolerance. And so getting alcohol into the brain fast presumably circumvents acute tolerance, knocks the hippocampus offline, and increases the odds of having a blackout. So let's look at this just for a moment. What these graphs show, I'll just tell you the take-home point here. These graphs, the one on the left is blood alcohol levels in males and females given the same dose of alcohol. And then on the right, it's the blood alcohol curve in people who either had a meal in them or not, a fasted condition or ate a meal. So if we start on the left, what you'll see is that at the same dose of alcohol, even adjusting for body weight, females reach higher VACs than males. Why is that? You might hear it's because of enzymes in the stomach. There's really very, very mixed evidence. What's more than likely the primary reason is just body water. Females carry a higher percentage of body fat. There's less water in the fat. So therefore, in a male and a female of the same size, the female has less water floating around. So when a female drinks alcohol, you get more alcohol concentrated in that amount of water. Therefore, more gets to the brain and affects organs. So that's part of why being female probably plays a role in blackout susceptibility. And on the right, you can see that if you have a meal in your stomach, there is a drastic difference between how quickly the alcohol gets in and what your peak BAC is. It's huge. In this particular graph, it's a little bit bigger than what I've seen in other studies. Usually it's about a third. Your peak blood alcohol level is about 1/3 lower if you have food in your stomach when you drink. So that's a very protective effect to have that food in the stomach. So being female, drinking on an empty stomach, drinking fast, these are things that increase the speed at which alcohol hits the brain, and that seems to circumvent acute tolerance, which leads to a greater likelihood of blackouts. And again, story could change. What do blackouts tell us? If blackouts aren't necessarily an indicator of alcoholism, what do they tell us? Well, all the studies, I'm just going to summarize all the studies that I know of on this very quickly. We know that having one blackout really only tells you you drank enough under the right circumstances that time to black out. One blackout can still be associated with a greater risk of different harms, but it's really once you get into more frequent blackouts, 1 to 2, 3 or more, the more blackouts somebody reports, the more likely they are to have other indicators of a problem with alcohol, trouble regulating their consumption, problems with their relationships because of drinking, difficulty maintaining obligations because of drinking. We know that blackouts predict being injured and ending up in the emergency room. If you look at college students who do and do not black out, those who black out are more likely to end up in the ER from an alcohol-related event down the road. So the frequency of blackouts, more than just the yes/no determination, really is where blackouts become valuable in terms of predicting other problems. But you got to dig a little bit deeper than just did you or did you not have a blackout. The researchers in the alcohol field have developed, this is just a few years ago, they developed a scale which they call the alcohol-induced blackout measure. I'm just mentioning it here in case anybody wants it. You can get these slides. I put the link in there. But it's a way to kind of assess the severity of your experiences with blackouts. And they have shown that higher scores on this blackout severity measure are associated with a bunch of other negative alcohol-related outcomes. The question comes up about, well, I know what I think blackouts are, and you probably know what you think blackouts are, but what if people don't agree on what blackouts are? What if we're asking people about blackouts and we're assuming blackouts must be bad? As I said, blackouts are associated with bad things. What if people don't feel that same way? What if young people, for instance, don't have the same attitude? And that's the case. Over the last 2 decades, as research on blackouts has expanded, the people have gotten more used to or familiar with the term blackout, and it's sort of lost some of its. It's just not as scary to young people as I think it is to some of us adults. And so I want to read you this quote from a paper by Miller et al., 2018. They asked students basically about their experiences with blackouts and what they meant to them. Students indicated that blackouts occur along a continuum with en bloc blackouts at the extreme. They also stated that the term blackout drinking does not always imply memory loss. It took me a long time to figure that out, by the way, that my daughter's in college and she had to explain to me, blackout drinking does not necessarily mean you drink to a blackout. It just means that you you drink a lot so that you're seriously impaired, so that you might be blacked out or you might not, but it's just a severe level of impairment where you're having fun and you might not remember. Participants reported higher rates of brownouts, fragmentary blackouts, than blackouts. They reported less negative outcome expectancies and attitudes, meaning that people who black out, they don't really think of alcohol as negatively as people who don't black out. Rather than thinking alcohol is worse, they don't think it's as bad or as dangerous. People who black out have greater approval for alcohol, higher prevalence estimates for how much everybody else drinks, lower self-efficacy, meaning that they don't think they could regulate their drinking as much, for instance, in social settings, and stronger intentions for brownouts and blackouts. So to students, it can actually be blackout drinking can be an objective, but it's not necessarily about the blacking out, but they also can want to drink to experience brownouts and blackouts. So whether they're positive or negative seems to be in the eye of the beholder. I'm just going to pass on this slide, but it's in here. This is an interesting study that just looked at how people feel about blackouts. What do they tweet about their blackouts? Like one person said, I black out and it's just autopilot from here on. Okay, I know that I've pushed the time envelope. Let me wrap this up. In terms of the legal implications, Goodwin was asked about this, throughout his career, and he concluded in 1995. He said, our findings have legal implications. Blackouts have rarely been held in attenuation for crimes, but lawyers continually try. I receive calls. When I tell the lawyers what we found, they usually don't call back. What we found was that remote memory was intact, but that people had trouble with short-term memory, which meant that during a blackout, a person would be able to recite the 10 commandments and know the consequences of robbing a bank. It was simply that he would not remember these things 30 minutes later or the next day. He knew right from wrong at the time of the act, and this appears to be the crucial factor where the law is concerned. There have been quite a few papers on this written before or since then, a lot of mixed conclusions, partly because of misunderstanding about what blackouts are. If you believe that blackouts strip away free will, then you could believe that the blackouts mean you're innocent of a crime. If you believe that somebody can still know right from wrong, then you might conclude that blackouts do not mean somebody is innocent of a crime. So a lot of the conclusions in the literature on this seem to depend upon what one's understanding of blackouts is. Okay, wrapping up, blackouts are relatively common. They're not consistent with passing out. Blackouts don't cause behavior change. They reflect the impact of alcohol on memory circuits. Risk factors include anything that causes the BAC to climb rapidly, like drinking quickly, drinking on an empty stomach, or being female, or having a gastric sleeve. Taking alcohol with benzodiazepines or these Z drugs is a recipe for blacking out. Genetic susceptibility to blackouts occurs, and the frequency of blackouts, not just the presence of one blackout, is associated with alcohol problems. Thank you.
Thank you so much.
Sorry for going over. I wasn't paying attention.
That's okay. People are still on, so everyone was interested. All right, lots of questions. One individual says they're aware of an old paper relating intoxication to altitude. Is there any research suggesting that blackouts may occur more often at higher altitudes?
Oh, that's such an interesting question. I would suspect that's the case. I don't know of anybody's looked at that, but I think, remember, anything that already impairs your cognition makes it easier for alcohol to impair your cognition. So if your memory is already, say, impaired and your attention's already impaired, it seems like it probably would take less alcohol to get you to the point of blacking out. But I don't think that's been done. Great question.
Brownouts. Are those synonymous with fragmentary blackouts?
Brownouts? I think so, yeah. I think the terms, I think all the terms, the old terms could be replaced. Blackout is probably not the best term. Fragmentary captures the gist, but it's kind of clumsy. En bloc, we could just say partial complete blackout. But in general, when people say gray out or brown out, they seem to mean fragmentary or partial. When people say blackout, they tend to mean complete or en bloc.
Gray out. How is that related to alcohol use and blackouts?
I think gray out and brown out are basically the same. It's just a different way of saying it's not quite a blackout. It's just a shade, but it's a darker shade than full memory.
Okay.
Again, I think we probably could replace these terms with something better.
Real quick, Alex, do you want to jump on real quick and address the issue that everyone's having with the
Yep, thank you. Everybody who's trying to get CEs, please give the server a moment. It seems to be overloaded, so everybody's getting a kickback that they're banned, but that's actually not the case. They just need to wait and try again later. If you still have issues, feel free to reach out to me directly, apond@salud.unm.edu. Thanks.
your email address in the chat so people can grab it? Hopefully he heard me. Okay. Next question. How do we know that the mechanism of a blackout is in the transfer from short to long-term memory and not retrieval functions from the long-term storage of memory?
Well, I think we know that for a couple of reasons. One is that during blackouts, one of the hallmarks is that people can talk about their childhoods while they're in a blackout. While they're failing to create new memories, they're still able to the whole time explore. That's why it's so hard to know somebody's in one, because they could be talking to you about what you did earlier in the day together perfectly articulately, but then in the meantime, they're not making a new memory. So it doesn't seem to be about long-term storage. This just to make sure, in case the questioner is thinking something a little different. There is this notion of state-dependent memory, where it's that the information gets stored, but the next day while you're sober, you can't get it back because it was created in that state. And so, and you'll hear anecdotes about that. People hide their booze and they can't find it until they get drunk again, and then they know exactly where it is. But those types of things, people have studied that. People have studied state-dependent memory and alcohol and not found compelling evidence that it serves, that works. So the blackout is not just that the information is there, but in a different state. It just seems to not be there.
Next question is, what is your current view, or what is your view of the current recommendations for limiting alcohol? So no more than 2 drinks per day for men for health reasons. Do you think this research is sound?
Oh, well, the way I come at it is 2 things. What do we know about the risks? And then the fact that people have to make their own choices. I think that people should drink what they're comfortable drinking. I can tell you that there are risks involved in drinking different levels. And once you get above that level, 1 or 2 drinks a day, 1 for a woman, 2 for a man, you start to get an increase in the risk of certain harms. But it's really a personal choice. We know that now for breast cancer, 1 drink a day seems to be sufficient to increase the risk. There are lots of behaviors we engage in that are voluntary, that carry risks. Riding a bicycle carries a risk. You can wear a helmet to reduce the risk. So I think this is an individual choice about how much somebody's comfortable drinking. The research seems to suggest that if you want to keep the risks to a minimum, you want to stay under 1 or 2 a day.
Are you aware of any significant changes that have been made to the new DSM in terms of how we diagnose alcohol use disorder?
Yeah, yes, a couple things have happened. One is we went from the DSM-4, which defined an alcohol use disorder as abuse or dependence, and the DSM-5, it's now a spectrum, mild, moderate, or severe. Took mostly the same questions, added in a question on craving, and now you're, rather than having alcohol abuse or dependence, you have mild, moderate, or severe. But putting those questions into practice has caused some consternation, because in one of our national surveys, the prevalence of DSM-4 alcohol use disorder was about 5% in 2019. In 2020, they went to the DSM-5, and now it's over 10%. So we added an extra 15 million people that now are considered to have an alcohol use disorder. So it's a slight change in the questions, but for some reason it translated into a big change in our estimate for how many people have a problem. I think it comes down to a couple of basic things. Are you drinking in a way that alcohol is disrupting your life and negatively, relationships or work or financial? Is it interfering with your life? Do you have a hard time regulating? Those 2 things, I think, are enough for any individual to sort of assess their relationship with alcohol. You don't necessarily have to go to the DSM-5. It's just, is it getting in the way? And do I have difficulty keeping it to a minimum? Those 2 things seem to be pretty predictive of problems.
And any major changes with the 5TR that you know of?
Oh, I don't know. No.
Okay. Can you address long-term effects of alcohol and memory, and can harm be mitigated by becoming abstinent?
Oh, yes. Well, I mean, I'll do the second one first. There's seems to be no question that the brain does a lot better without heavy drinking. And so abstinence tends to bring with it improvements in functioning. There's no question about that, whether it's memory or attention or mood. Of course, early on, abstinence can really wreak havoc on your attention if you drink enough to be in withdrawal. But long term, there's plenty of evidence of improvements in functioning. There's also plenty of evidence of damage to the various aspects of cognitive function with long-term heavy drinking. Even if you drink enough to get drunk once, the next day during the hangover, you have impairments, and surgeons don't perform surgery as well, pilots don't pilot as well, etc. But with chronic heavy drinking, alcohol erodes the ability of these brain structures to do their jobs, and you get some lingering effects on attention, memory, emotional regulation. And so, yeah, that kind of impacts day-to-day cognitive functioning. So yes, heavy drinking can disrupt cognitive functioning long-term, but yes, with abstinence, particularly over the first 6 months or so, there are real improvements in cognitive functioning.
All right, last question. There's still so many left, but
I'm good. I'm not in a rush.
Okay, then we'll do a few more. Here's another one. Within a biopsychosocial model, how does culture interact with the expression of physiological effects of alcohol use?
Yeah.
Specifically, it's hard to make sense of the extremely different ways that typical alcohol consumption and typical effects vary based on culture, given that alcohol has selective effects on the brain that are presumably similar across cultures.
That's a wonderful question. No doubt about it. One of the reasons that people think Americans drink so much more than the Europeans seems to be that when we Americans drink, we're more likely to get loud, obnoxious, hoot, holler, party, riot, these various things that are sort of normative expressions of alcohol in certain contexts. Whereas people in France might drink a lot more, might have a greater likelihood of damaging their livers, but they culturally expect themselves to be, to keep it together and not, be obnoxious. So there's certainly cultural things that influence how intoxication manifests. And, one interesting example of that is in laboratory studies where you give people placebo alcohol, they start to behave in whatever way they think they're supposed to behave. How do you know how you're supposed to behave? That's shaped by your culture. We learn at a very young age what to expect about what people do when they drink, how they act. Are you more likely to express yourself this way or that way, or what's acceptable behavior? We learn that culturally, and even before we start drinking. And so then if you give us fake alcohol, we start to act that way even without the alcohol. So again, no doubt, cultural expressions of intoxicated states vary tremendously based upon our expectations about what we're supposed to do in that state. If I could just say, I think for a very long time, people got away with saying, well, I was drunk. And as long as what you did, everybody assumed was just part of being drunk, you got away with it. And I think it seems to be that people are holding people more accountable for that. Like, you were drunk, but there's no excuse for that. And so again, the culture kind of will change how people express their intoxicated states.
Okay, so I just got a message that our REDCap survey is down, or the server's down. So for everybody that's still trying to get your CE certificate, we are going to work on getting that up. So my suggestion to you is just copy the link, save it, and go back tomorrow. We'll probably send an email out to everybody when it's back up. We will make sure that it's open for, longer than the normal 48 hours to accommodate this. But we will work as fast as we can to get that back up. Okay, next question is, do you ever testify in cases where a person wakes up the following morning after accusing somebody else of rape because they can't recall consenting?
Decades ago, I did some expert testimony on cases like that, a lot of court-martial cases in the military. And I'm happy to say I don't do those cases anymore, and I can't do them in my current position. I always found them very icky, and but I tried my best to just stick to the science and just talk about what we know happens during these things, what seems to occur. But I will tell you my conclusion from that. This is not a scientific conclusion. This is just from my personal experience, having been on the science side, but also a little bit of that court-martial side. Blackouts are blackouts. Blackouts are missing memories. People can be raped during a blackout, no question at all. They can have no memory, and they could be conscious and functioning and aware at that time, but still be sexually assaulted. But people can also, in a blackout, initiate sexual encounters, drive cars, take money out of the bank, engage in these very complex behaviors. So the point is, the blackout really tells you nothing about what happened in those events, other than one or both of the parties can't remember what happened. That's it. The presence of a blackout only tells you that the person can't remember. It has, the only implication it has for what transpired during the event is that it tends to take a considerable amount of alcohol to get to a blackout, and that it's possible the person could have passed out at some point, or maybe they weren't in a blackout at all, they were just passed out. I mean, those are the relevant questions. But if we know a person experienced a blackout, and that's what we know, it tells us nothing at all about guilt, innocence, victim, crime. It just doesn't. You've got to have more information than the presence of a blackout.
With that, there's a lot of questions about blackouts being used as a defense in court.
I kind of figured they would be coming. Yeah.
Yeah, or psychiatric defense for criminal offenses.
Yeah.
Anything else you want to add to what you just said?
I mean, again, I'm coming at it as a scientist reading that literature, the legal literature, and it seems to me that the argument seems to hinge around the mens rea, the ability to formulate intent, and whether somebody who's in a blackout is not able to formulate intent. And, it's a question that, fortunately, as a biological psychologist, I don't have to answer. I'm curious like everybody else. But I can tell you that people can engage in very complex behaviors in a blackout. People can buy plane tickets and travel. People have bought property. People write books. People engage in all kinds of behavior that takes complex planning and thought. They just don't remember. So again, the presence of the blackout seems entirely insufficient to address the question about whether somebody was able to, form mens rea. Just all we know is they were missing the memories. Somebody would have to argue that the alcohol took away that ability. The alcohol itself, not the blackout. The blackout doesn't take anything away. It's just a symptom of drinking an excessive amount. I hope that was clear, the distinction between the blackout and the alcohol. I mean, blackouts are just they're just one symptom of intoxication.
Yeah, I think that makes sense. So alcohol does lots of things. One of those things is a blackout, but there's other things that it can do. And those things potentially.
Those are the things, exactly. Yes, so the take home point is that blackouts don't cause anything. Yeah. Nobody does anything because they were in a blackout. Right. They may have done it because they were really intoxicated, and so intoxicated they had a blackout, but the blackout is never the causal agent. It's always just an indicator of consuming alcohol in a certain pattern and being susceptible to them. Okay, I think we're going to end for today. Thank you so much. Oh, my pleasure.
Such a great topic, and we really, really appreciate all the time that you spent putting it together for us and presenting today. So thank you.
My pleasure. And I tried to put a lot of material in the slides with links, so if people need more. And please don't hesitate to reach out to me. But I do want to state again, I don't do any legal stuff. I'm not interested, and I can't do it if I wanted to. But if you ever want to talk about the science of blackouts, please reach out. I'd love to talk.
Perfect. All right. Thank you so much, everyone. We're going to jump off in just a couple of minutes. Try and grab that link, and then we'll be in touch over email about when to go back on to complete it. But Dr. White, thank you. You have a wonderful day.
Thank you, Julie. Take care, everyone.
All right. Bye-bye.